there's three laws that you're going to use in order to manipulate and solve these. So the first is called the product rule, and it goes like this. And then I'll show you an example of it. It is if you have two separate log expressions like log A plus log B, then and you're trying to solve an equation, you can't do it without combining it into one expression. So you would just get log of A times B, and you could check that. You could plug any two numbers in and try it. So for example, if I had log of 5 plus log of 3, that would be the same as the log of 15. And if you tested out those numbers, those would be equivalent. The quotient rule then is log A minus log B. When you subtract two different log expressions, you can rewrite it. And what do you think this is going to be? When you subtract, instead of multiply, you divide. Yeah. So it's going to be log A over B. So for example, if you had log 10 minus log 2, that is not equal to log 8. Okay, it's equal to log of 10 over 2, which is 5. Yeah. And now the most important one. This is what actually helps you solve log equations. This is the most important, the power rule. It says if you have log base B of m raised to the n power, which you've seen, we've done warm-ups and examples, then you can take this exponent n and you can actually move it down to be the coefficient. So it becomes n times log of b, log base b of m, like that. So like if I have, it's easier to see with an example. If I have like log of 5 raised to the x power, that is equivalent to x log 5. And what missing base? I can add a base here if I want. I can write the number, but what's the base automatically? Yeah, there's an invisible 10 here, but you don't need to write it. And this allows us to actually solve equations. When we can move the exponent that we're trying to solve for to the front of the equation, then we'll be able to solve them. You'll see. So the exponent becomes the coefficient. That's what's happening there. So let me write what happens here. The exponent becomes the coefficient. Coefficient is a number in front. Okay, so what we're going to do is we're going to use this to practice condensing some. So the directions are going to be condense these expressions. So let's say number 1, we have log 4 plus 3 log 3 minus log 12. And we want to rewrite this whole thing as one log expression. So what we would do is we would take log, we would go the opposite direction. We would move this 3 up. So it's log 3 raised to the 3rd power. And then this is equal to log 4 times 3 to the 3rd. We can combine, when you add 2 logs together, it's the same as multiplying, minus log 12. And then, of course, when we subtract, it's the same as division. So you get log, this is 3 to the 3rd is 27 times 4 is 108. Minus log 12, and you get log 10. Now we just make it into one log expression, 108 over 12, which is log 9. That's the final answer. So you can use it to do that. You can also use it to evaluate expressions. Use the laws to evaluate expressions. So let's say we have log base 5 of 8, okay? So so you know already to convert that, what you're asking is 5 to the what power equals 8, right? And here's where I started the unit. I said, okay, how are we going to solve for x? So what you do is you take the log of each side. So number 1, take the log of each side. So it'd be log 5 to the x equals log 8. And step 2 is you use the power rule that I just taught you to bring the exponent down. So instead of log 5 to the x power, it becomes x log 5 equals log 8. And then step 3 is you just divide by the constant like you would a regular equation. Because log 5 you can do on your calculator. There's a button you've been practicing. So if you divide both sides by log 5, log 5, log 5, you'll have it. You'll have the answer. You just have to be careful to make sure it does it in the right order. So if you do log 8 on your calculator and hit enter, and then you divide by log 5, you'll get the exact decimal answer. Well, unless you round, it won't be exact. Log 8 divided by log 5. So you have to be really careful. Do log 8, hit enter, and yeah, 1.29. 1.29. And it makes, that should make sense that if you raise 5 to a power that's a little more than 1, that you would get 8. So this is how you use logs to solve equations. And there's a shortcut for this called the change of base formula. Change of base formula. And it goes like this. Whenever you have log base b of a, it's the same as log a over log b. And we just saw why that happens using the rules. So log base 5 of 8. So for example, log base 5 of 8 equals, the way you evaluate that is you take log 8 and you divide by log 5. And we saw that happen right here, log 8 over log 5.